Okay, so we've been talking about deduction and induction, and I want to finish up that discussion today. These are the two different kinds of inference. As you will recall, you can draw an inference in two ways, either deductively or inductively. And as you will recall, I explained last time that a deductive inference has a conclusion that follows of necessity, and an inductive inference has a conclusion that follows as a probability, right? We notice that almost all your daily, well, the vast majority of your daily inferences are inductive, not deductive. If every time you go home, you see your mother's blue car in the driveway, and every time you see her blue car in the driveway, she's been home, that doesn't mean the next time her blue car's in the driveway, she will be home. It doesn't mean it will be a necessity, right? But it's a probability. It's a high probability. If, say, it's happened 500 times in a row, and it's never happened that when her blue car is there, that she's not there, right? So it's a good, high probability. It's a very good inductive inference that if you see her blue car there today, that she's there today. Of course, this could also be the one time that she just, got a ride with somebody, or she was abducted by aliens, or just disappeared, or whatever. It's nevertheless a high probability. So if we take that same inference, we can make it deductive. That is to say, we can take the same premises and draw a conclusion that follows of necessity. But when you do that, there's kind of a trade-off here. In other words, you get a conclusion that is not very useful, and you'll see what I mean. It will follow of necessity now, but it will not be very useful. So again, let's think about that same argument, that same inductive argument. If we put it down into a series of premises, it would be like this. The first premise would say, I'm just going to draw a line for the premise. Every time her blue car's in the driveway, my mother's home. My mother's blue car's in the driveway. The conclusion is, therefore, she's home. And that's supposed to lead to that conclusion. And of course it does inductively. It's a probability. It's not a necessity. So how can I keep those same premises and draw a conclusion of necessity? Well, I can do that. But as I said, the result will be a conclusion that's not very useful or helpful. So let's think about it again. Every time her blue car's in the driveway, she's home. Her blue car's in the driveway. Therefore, there's a driveway. Okay, that follows of necessity from the premises, but it's not very helpful. You already knew that, right? You knew there's a driveway. Here's another one, same thing, deductive. Every time her blue car's in the driveway, she's home. Her blue car's in the driveway. Therefore, there's a blue object. That follows of necessity. Again, I made it deductive, but you see the trade-off there. In order to get a conclusion that follows of necessity, I get a conclusion that is not very useful and doesn't give me genuinely new information, right? Okay, so one last thing I'll say about deduction and induction, and that is that oftentimes in sort of real life, so to speak, when a person doesn't want to believe something, someone wants to resist accepting some conclusion, the person will often ask for a kind of proof that of course no one can provide. That is to say, the person is asking for deductive proof, right? So for example, well, here's an example where for cultural and religious reasons people demand a kind of proof that is virtually impossible to provide. Remember, I said when it comes to deduction, there aren't many cases where it applies outside of math and logic. As I said, I cannot deductively prove that you exist. You cannot deductively prove I exist, right? You can inductively prove it. So, for example, here in the South, there are a lot of people that for religious reasons refuse to accept what science tells us about the evolution of the human species. Well, I found that if you talk to such people and you tell them, well, look, what about the mountains and mountains of proof and evidence we have from the world of biology? And I find that some of them will just declare that all of that is not really proof. And of course, if you ask them, why isn't it proof? Why isn't what scientists call proof? really proof. Why are all the scientists wrong? They don't know this terminology, but what they're asking for is deductive proof. And of course, we cannot provide deductive proof for the evolution of the human species. We can't provide deductive proof for the boiling point of water. So as a result, that is the case that for religious and cultural reasons, people refuse to accept. People who refuse to accept something demand a kind of proof that, of course, no one can provide, deductive proof. All right. Enough about deduction and induction. We know how it works. We know what the distinction is, I hope. Let's go on and understand the rest of what we need to get to understand logic. Okay, so there are a few terms that we can use more or less interchangeably. Proposition is one of them. That is to say, these are just about synonyms, and they're often used synonymously. There are distinctions between them, but they're often used in such a sense that they're basically synonyms. Proposition, a declarative sentence, right? In other words, vis-a-vis an interrogative, as opposed to an interrogative sentence or an exclamatory sentence, right? Let's see, an assertion, a claim. These are all more or less very close to being synonymous. Now, the one we use usually in logic here for these purposes is proposition. So let me explain what a proposition is. A proposition, and this is a definition I want you to remember, okay? A proposition is something that has truth value. Okay, now let me write truth value down here. Truth, we usually hyphenate it. Truth value. Now, that's just, truth value is just a fancy term for saying it is true or false. That's all. That's all it means. It's true or false. It's just that in English, unlike Romance languages, we don't have very good, clear terms. And maybe you've noticed this. For speaking of, say, the truthness or the falseness or the falsehood or whatever, it doesn't, there aren't very good words. Like I said, in most Romance languages, there are. So we say truth value. So if I ask, what is the truth value of that proposition, or what is the truth value of that sentence, I'm simply asking, is it true or false? So there are only two possible truth values. There's true and there's false in the kind of logic we're doing, okay? There's no middle, there's no talts or foo or something like that. It's true or false, okay? All right, so that's what a proposition is. And notice that propositions, see, this makes for a good quiz or test question, is the following a proposition? See, a lot of things you say every day, chances are not propositions, and a lot of them are. If I say to you, or if you say, today is Thursday, that's a proposition. It's either true or false. If I say the light is on, that's a proposition. It's true or false. If I say the square root of 9 is 27, that's true or false. So, if you ask, however, if you offer the following sentence, say, or proposition, are the lights on? That's not true or false. That's a question. It's an interrogative, right? If you say, go in peace, that's not true or false. If you say, shut up, shut the door, those are not true or false. Go to hell, that isn't true or false. That's a command or a wish, right? So it's not the case that everything you say is a proposition. A lot of things you say are not propositions. A lot of things probably you say every day are not propositions. Everything that is a proposition has truth value. Everything has truth value is a proposition. So notice this about all of this. You don't have to know what the truth value is to know something has truth value. Okay, in other words, you don't have to know which it is, true or false, to know that something is true or false, that it's one of the two, that it's a proposition, right? Okay, you don't have to know which one it is. So, say for example, I say, I don't know, I say there are more than 3 people on my front yard right now. Okay, regardless of where you are, you know that is either true or false without knowing which one it is. So in other words, you know it's a proposition. See, you don't have to know how many people are on my yard. You don't have to know if it's true or it's false. Let's assume you understand and agree that I have a yard, okay? You know it's a proposition without knowing whether it's a true or a false proposition. And that's going to happen in many, many cases. If I say there is a lake on the moon made up of lemonade, you know that's true or false, right? Regardless of now you might say, well, I'm pretty sure that's false. Okay. Let's see. There are more than 20 billion stars in the Andromeda Galaxy. Okay, that one you may not know, but you can tell that's a proposition because it's either true or false, right? So you don't have to know what the truth value is to know that something has truth value, right? In some cases, you may not be able to find out the truth value. Not for certain. If I say there's a man right now on the planet Neptune jumping up and down, singing the national anthem named Kanye, you don't know if that's true or false. You're pretty certain it's false, but you can't know for sure it's false. So that's one you can't even determine. But one thing you do know is it's a proposition, right? You know it's a proposition. Keep this in mind. If it's a proposition, you can always lie about it. Yeah, that's one way to keep it in mind there. If it's a proposition, you can always lie about it. Now, these here, as I say, we won't really use very much. I'm just showing that they are they're close to being synonymous. When logicians wear a tie, when they're wanting to be precise, they'll draw a distinction between a sentence and a proposition by saying, well, a sentence is what you have in a book, right? What is in here are lots and lots of propositions. Lots and lots of sentences. It's also something you say that comes out of your mouth. That's a sentence. But a proposition is what you're thinking. It's in your head. Yeah, I'm saying logicians, when they want to be really precise, make that distinction. Normally, we'll call something written down a proposition also. We'll call it all propositions, sentences, propositions, declarative sentences, not questions, not interrogatives. We'll call them all propositions. It's only when we want to be precise. So that distinction, you don't need to even remember. It won't be particularly important for us between a sentence and a proposition. In case you're curious, you see, you could have different sentences in the same proposition, right? For those of you who want to think a little more deeply about this. Let's see. Here are two different sentences, but they're the same proposition. Today is Tuesday. Today is not Tuesday. See, those have the very same meaning. They are saying the same thing. They're the same proposition, but they're not the same sentence, and I can prove that by just counting the words. Today is Tuesday. Today is not Tuesday. Different sentences, same proposition. In fact, here's that same proposition again in a third sentence. Today is not Tuesday. Or today's not Tuesday. Or today's not Tuesday. Those are all different sentences, and they're all the same proposition. Or you could have different languages. You could say, he is in the house, or elle está en la casa in Spanish, or il est dans la maison in French. Those are three sentences. They're the same proposition. So there again, there's a slight difference between those two, but we don't need to get too caught up in that. All right, so one other thing I'll say about propositions, this is a good rule of thumb, something to remember here. If it's a proposition, you can lie about it. Now, think about that. If in doubt, ask yourself this. You say, I don't know if this is a proposition or not. Ask yourself, could I lie about it? Like if I know the truth value, if I did know the truth value, could I lie about it? So, for example, you might, if I put on a test, is this a proposition? And then it said, Tom is a really disgusting person. And you might think, well, wait a minute, that's really a matter of opinion. Okay? Could you lie about it? Yeah, sure could. Okay? Then it's a proposition. Right? That clearly is a proposition. Now, obviously, lots of times we say things that are technically propositions. We don't mean them to be propositions, like in poetry or lyrics of a song. If you said, we are two ships floating in the night. See, literally, that's a proposition, because either you are a flotation device, large flotation device, or you're not. So that is technically a proposition. But of course, it's part of a poem, so you don't mean it that way, right? I even back up and clarify that a little bit. You mean it in a slightly different, or certainly in a metaphorical way. So, proposition is one thing. I've used the word premise already, and I said earlier that I would give you a definition here. The plural is pronounced premises, right? In case you're not aware of that, the plural of crisis is crises. Plural of base is bases. So, what is a premise? Okay, so a premise, this is the definition, I want you to remember this. A premise is a proposition when it functions in an argument to lead to a conclusion. Okay? A proposition is a sentence when it functions in an argument to lead to a conclusion. All right? That's a proposition. One more time. A premise. Premise is a proposition when it functions in an argument to lead to a conclusion. So that's going to mean, you'll notice without much reflection here, that all premises are propositions, but not all propositions are premises, right? So let me clarify here. When we speak of an argument, like earlier, I wrote, a couple of lines which were premises and then a conclusion. The premises lead to the conclusion. All right? Like if we said, let's see, all x or y, if I just use such variables there, right? And then I said something like, all y are z, conclusion, therefore all z are x. Right? So these are premises, and this is a conclusion. Right? Each one of the three is, of course, a proposition, but the first two are premises, and this one is a conclusion. But they're all propositions. Why are they all? Well, because they all have truth value. Either all z really are x, or they are not. So these are propositions, but the first two are also premises. So then not every proposition is a premise. This is an example of one that's not a premise. But every premise has to be a proposition. Okay? Now look, again, this is what we call an argument. So I guess I've been taking it for granted, but let me clarify that you understand. When we speak of an argument in logic, we don't mean like, throwing things, right? What we mean by an argument is a rational process, okay? Or ratiocination, if you want a fancy word for it, all right? A rational process, a ratiocination, that's an argument. Now, we need to talk a little more about how arguments work, but at least we understand now what a proposition is. Now, to go further with this, we know that we get logic from Aristotle, right? He is the father of logic. He's the one that gave us our logical doctrine. Now, let me write a sample proposition down. I'm going to put here, some cats are dogs. That sounds like a weird proposition, but there was a cartoon for a while where half the star was a cat on one side and the other side was a dog. I don't know if you ever saw it. It like screwed up the zoology of a whole generation of kids. Cat dog, is that? Or dog cat? Is it dog cat or cat dog? Oh well, it doesn't matter, guys. Relax. Okay, so this is just a sample. And remember, the father of logic, Aristotle, analyzed all this to a very deep level. He told us there are 4 parts to every proposition, every proper, or shall we say Aristotelian proposition. Okay, 4 parts. And that's the last thing I want to do right now, is to identify the 4 parts, okay? And they're kind of obvious. Okay, so the first thing is the subject. There's a subject of every proposition. It's just what the proposition's about. No big deal. Obvious, piece of cake, taking candy from a baby, okay? If I gave you a proposition on the test and said, all right, identify the subject. If I said all maps, well, you can't see these maps here. All maps are blue. Maps is a subject. Some whales are shy. Whales is a subject. No chairs are wooden. Chairs is a subject. Some Homo sapiens are ambidextrous. Homo sapiens is a subject, right? Very easy to find. Now, this is what we call the predicate. Okay, the predicate of a proposition is just what you're saying about the proposition. Whatever you're claiming or saying about the proposition is the predicate of the proposition, all right? So every proposition, every proper Aristotelian complete proposition has a subject, and each has a predicate, okay? Very simple. All cats are dogs. By the way, though this is the way propositions normally come out of our mouth, the way we normally speak, it doesn't have to be that way. Instead of saying all cats are dogs, I could say dogs is what all cats are. Cats is still a subject. Dogs is what all cats are. That's still a subject, but that's just an unusual way of speaking. Sometimes, you know, for literary purposes and literary effect, people will do that, but normally it's not like that. Thirdly, there's what we call the quantifier. Okay, the quantifier. That's real easy. It's just the how many word. All right, the how many. So instead of saying some cats are dogs, I could change the quantifier and I could say no cats are dogs. Many cats are dogs. Some cats are not dogs. No cats are dogs. Lots of cats are dogs. Wheelbarrows of cats are dogs. Stadiums full of cats are dogs. Many cats are dogs, on and on. Aristotle, however, pointed out to us, showed us, that logically speaking, there are only 3 possible distinct quantifiers. Okay? There's all. I could say all cats are dogs. There's no, which means none. No cats are dogs means none. Or I can say some, as I did here. And from a logical point of view, according to Aristotle, and I think you will agree, that's all there are, right? All those other ones, quantifiers, simply reduce to one of these, and mostly they reduce to the word some. If I say many cats, I'm saying some. If I'm saying every cotton picking one cat, I'm saying all, right? If I say lots, I'm saying some. Wheelbarrows, I'm saying some. Stadiums full of cats or dogs, I'm saying some, right? Either I'm talking about the entire subject class, none of the subject class, or a portion. So, those are the 3. And then finally, the 4th here, this gets a little Latin term, copula. It's called the copula. Now, all the copula does is it connects the subject and the predicate of a proposition. That's the copula. All right, the copula connects subject and predicate of a proposition. This is an old Latin term, where we get the term couple, copulate, couplet, etc. All comes from copula. I mean, it's originally a Latin word, but it's an English word too now. Okay, used by grammarians a lot. All right, 4 parts of a proposition as given to us by Aristotle. Next time we're going to go further, and we're going to head toward what's the really important part of all this, which is complete arguments. We're going to deal with that, and that's going to be the biggest part of our test. So stay tuned, guys. Bye-bye. Keep the candle.